This is a tutorial for the momentum simulation here. And we'll click on this. And you start off with a couple of balls right here, and you can move them around. But the idea with the basic simulation, if you kind of snap them to the same area, it will snap them to the same level. And this lets you make a really simple conservation of momentum lab. So each ball, once you've highlighted a ball, you can change its mass to whatever value you like, but I'll keep it simple, having them both be 1 kilogram. And if you drag from the center, you can create velocity vectors. Okay? You can angle them, and you can see 12 meters per second south, 60 east, for example. If you want to change it, just click from the center again. And you could, for example, start with just it going east, and you could do a conservation of momentum. It will, of course, hit the second ball, and the second ball will take that momentum. You can, of course, pause it. You can also just slow down the simulation. So, you could have this one going this way at 9 meters per second east, and your second ball could be 2 kilograms moving at 8 meters per second west or something. And you can have them bounce off, and you can record their velocities after the collision. And with a simple table, you could have the students confirm conservation of momentum in one dimension like this. You can also do glancing collisions. So for a glancing collision, you got a couple of options. You can just have it. I don't know if that one's actually going to hit. Let's speed that up. Yeah, that'll hit. You could do that and record their velocities afterwards. Or you could just move this one up a little bit and have it go straight. Really, whatever, you could set up whatever situation you want. And you could, test your conservation of momentum in 2 dimensions. You could even try and have them sort of hit each other this way. Although this one does take a little bit of planning because you don't always know if they're going to hit. Again, if they're moving too fast, you can always slow down the sim speed. So that's the first part. It just allows you to create conservation of momentum problems. You'll notice it says elastic at the top. If you click inelastic, then it will just make them stick together. So you can still perform a conservation of momentum. It will just have them stick together afterwards, and you get the idea. So when I do this, I have my students do a verification of the law of conservation of momentum in 1 dimension, and I have them create a table for elastic collisions and for inelastic collisions. If you don't want to have too much information on the screen, you can not show the arrows and not even show the values, and you can not even have the balls snap together. And what's kind of fun is, actually let's put them back on, is if you increase the number of balls, it kind of gives them random velocities, and you can just watch them bounce. Actually, let's make it elastic again so they don't stick together. You can just kind of watch them bounce around, if in fact they do bounce around. So that can be kind of fun. So that's the basic mode. That's the normal mode. We'll put those back on. I'll reset. The second mode is explosion mode. Now, you cannot give the initial object a velocity as you might be able to in some of the problems in a textbook, but you can tell it to explode into different numbers of pieces, and you can set its mass, for example. And so if you hit the explode button, that was a little fast, so let's slow down the sim speed. I'll reset it. If you hit the explode button and pause it, you can write down the masses of the different pieces and all of their velocities into components to confirm conservation of momentum again in that explode variation of the simulation. The next is, I made this simulation and it had balls bouncing off each other, so I made a pool simulator. This doesn't really have any educational value. It's just kind of fun for the kids. So you can, from the cue ball, you can kind of aim it and let it go. You know what, actually, sir, I'll go back to normal so I can get rid of show arrows and values. And you can see this X's. I did not make the side pockets viable. You can only sink it in the corner pockets. There you go. You can see I sunk the orange one. It doesn't really keep score or anything. It's just kind of fun for the kids. If you click on predict, I added a prediction mode so you can hit every shot. So if I, let's say, aim at the yellow ball here. So I'm aiming it so that the yellow line goes to the far corner pocket. And you can see that's what happens, although I scratched it. If you scratch, the game's over. You got to hit reset. I realized there's a couple other things I could show with this. I'll show diffusion first. So this will also show diffusion. So let me explain this. What I've got is I've got a bunch of red balls starting in the right corner and green balls in the bottom corner. And if you hit play, they will just bounce around. And if you leave the simulation for long enough, you should get about an even spread of both. If you pick hot temperature, it will just speed everything up. And so that's visual for diffusion. The final thing you can do is a ballistics mode, which you can show movie clips of people getting shot by a bullet and flying through windows and falling to the ground. There's all sorts of terrible examples of this in, you name it, any action movie. But you can show students that if it's, I've got a 75 kilogram person standing on frictionless ice, the simulation does not have any friction, and they're being hit by a 9mm gun bullet. This is an accurate mass and an accurate speed. And you can see they would only recoil at 4 centimeters per second. And the kids, of course, go, well, what if it's a shotgun? So I added like a shotgun here. And, you know, you'll recoil at a faster speed, of course, but still nowhere near flying out of a window. And just for fun, I also added a 50 caliber sniper rifle, which would probably just make a person explode, to be honest. But even if that hit you, that would be your recoil speed. So really the only way to make you fly through a window, like happens in the movies, is to hit you with a cannonball. So that is the conservation of momentum simulation.